Okay, so this is a configuration of a table that I put together. It has various widths of each individual station, so between 1400 and 1800, and then it comes with a variety of screens. I modeled everything that will be placed in the catalog so that we can export line drawings and we can create photorealistic renderings of it. And if we go here, as you can see, the configuration manager. So there's a 1400 module, which means an individual desk, and the width of individual desk is 1400. And then if we go to the 1800 module, you can see that it updates automatically. The way this is achieved is that each rail, there's a number of rails. Actually, different rails are used for the different widths. So I selected the correct rail and I reconfigured the whole assembly. The way the parts are positioned is the mates are made using the planes, which ensures that if you change the rail to a different size and a surface disappears, it doesn't break the mate logic. So I'll scroll through the different sizes and then I'll show you how things have been modeled. So for example, actually there's two T-screens, left screens and right screens. There's a different configuration. Now we can show you. Yeah, and here's another one. But the way it's achieved, so there are a few sub-assemblies. For example, this screen is made of two sections. So this is one assembly and it has three states. So if I open the model, sorry, I just opened only the straight section. We need to open the entire assembly, which means that we need to go here and open the assembly. So you will see that I have three different screens: left screen assembly, right screen assembly, and then a T-section assembly. There we go. So that's what I'm using, and I'm scrolling through those. Don't save changes, discard into the assembly. Now, if the way they're positioned, again, as I said, I'm using the planes rather than surfaces because in some configuration the surface changes. It's been trimmed differently, and then this breaks the mates. But if we grab this screen, for example, at the moment we're using you can see here the 1800 width table. Say for example we want a 1400 width table. These are the mates for this screen. So this is the screen, and we only have three mates. One is distance from the edge of the table, which is again the plane. That's the right plane of the table versus the right plane of the screen. So there's a certain distance, then you have the top, and then you have the front plane that are coinciding. But if you want to change the location, you just edit the feature, the distance. At the moment it's 1800. So if we make a 1400 for a smaller table, that will be updated automatically and the screen will be repositioned. You can do exactly the same for all the other screens. So this will be positioned at the moment at 360 millimeters from this edge. But if you change the dimension, it will give you a different location. And I can very quickly say I can convert this to a T screen or a right screen just by selecting the different configurations of this subassembly. The next thing, so if we go through this other settings, you will see that we have multiple configurations, and as you can see that this was updated for all configurations, the location of this screen. What happened is, I'm most sure that whoever works with the software very often is very familiar with what this issue was. It's not actually an issue, but that's how we set it up. So if you say just this configuration, you need to select only this configuration, change the location in this configuration only, or for all of them. At the moment we have it for all, so I will just bring it back to the original state, which is the 1800. But if you want just a specific one, you make sure that you select and specify only at for this configuration. Okay, now the table actually has all the different tables inside. So it's one module that contains every different possible tabletop. If I open the file, we can quickly see how this works. So if I open the file, you can see that there are, I'm not sure how many, but quite a lot of tables. This is the number in the bracket indicates how many workstations we have. So at the moment we have 2 workstations which are facing against each other. And then this is at 1400 width. We have the same thing but at 1500 width. There we go. And then we have a 1600 width and so on. And then we have a four desk configurations. And on each one, as you can see, that all the inserts, the location of the inserts is updated, as well as the location of the side cutouts. These are clearances for some metal brackets which are holding the center screens. But in some tabletop options, we also have side screens, which means that we need clearance cutouts on the side of the table. I'll show you this in a second. So let's go to the six workstations tabletop. And the way it's built, the way the model is built, so we have the cable cutouts. So we have one in the middle, which at the moment is active. There's 2 in the middle, which is suppressed and it's only visible in certain configurations. And there's 2 at the end, which at the moment is active. Center screens cutout, we have 3 at the moment. For the 2 berth tables, we activate the 1 center screen. Then the small side cutouts, they're deactivated at the moment, but I'll show you in a second how we activate them. And then we have the inserts. So we have 4 corner inserts. The way they are built, this is an offset from the overall, from the initial extrusion with minimal lines and data. Then you have four sets of holes for the T-leg. I believe this is not active at the moment. It's probably construction lines. And it's again distance from the size, and it's symmetrical so that we save data. The model is not very heavy. But if we go back to, the small side screen, so if we go to these configurations, you can see that the last 6 configurations, they have side cutouts as well. So for example, the 14200 at 1600, we have the same thing here but with side cutouts. So if I activate this, you will see that there are some small side cutouts appearing in the model. And this is useful because the table actually has all the variations and it's just one single module. One single assembly that has all the configurations for this tabletop. So if we close and we don't save any changes and we go back to the original model, for example, once I hide this screen, and that's the screen, if I hide the screen, you can see that there is no cutout here. But in some cases where you have small screens on the side, you need the cutout, which is a clearance for the bracket. I'll hide this one as well so that you can see both of them. There we go. And now we can quickly, if we decide to replace the screens with different ones, we can quickly just select the configuration of the tabletop which has the side cutouts. It will not break the model because there we go, you can see the side cutouts appearing at the moment. It doesn't break the model because what we use to align and position the top is the planes rather than any surfaces inside. Because if, for example, we use this edge or this surface here, once you have the cutout, it's a new geometry and then the mates will break and they will not work properly. So I'll close this model and I will open some of the other ones just to see how many we have. Let's see here. So these are all the cut assemblies for renderings. This is all the different variations that we have. But you can see here we have this module, which is the frame just the left section of the frame, then we have the right section of the frame, then we have the center section of the frame, and then they're put together. And then each one has actually different widths, meaning that it's using different rails. Let's pick something that is, let's try small side screens. Let's try this one. So it has a small side screens and without small side screens. And it's loading at the moment. There's quite a few components in there and quite a few sub-assemblies. Don't rebuild because it will just break the color at the moment. This is a video purpose. It did break the color anyway. But you can see 1400 with small without the side screens. Then we have 1400 with the side screens. There we go. Then we have 1800 without the side screens and 1800 with the side screens. So you can actually put all this in one single file, but it will be very heavy. That's why I decided to separate them in different files. So whenever you have the big screens, it's a single file. Whenever you have the small side screens, it's a different file. But this means that you can very quickly and easily create a configuration, custom configuration as per client's requests. It might take you a little bit to configure the individual module widths, but it's very easy to do. Don't save. So I think this is showing enough of the configurations for the bench desk table.